semua tak boleh Bagaimana yang lain? Semua tak boleh You can see it's MOE
Yeah, so can already.
Okay. Alright, okay. Tak apalah, MOE ke, this one no problem. Okay. Alright, we start with 9.2 calorimetry. I go to syllabus first. Let me check the syllabus. What is required in the syllabus? So 9.2 calorimetry. First thing, I write here. 9.2 calorimetry. Pernah dengar calorimeter tak? Pernah dengar calorimeter? Saya tak pasti mana anda pernah. Calorimeter kan. This is to what we call the measure the heat of a reaction. Any reaction lah. Kalau kita nak measure heat of reaction, then kita guna calorimeter lah. Okay. So here we are going to learn about calorimeter. Before we learn about calorimeter, you need to know two important definitions. Yesterday saya ada beritahu dalam video lesson saya pada kelas H5P2, H4P2 and K1P2 pun boleh tengoklah video tu. Okay. First, you have to define heat capacity. Okay, maybe I can read for you. Kalau ada nota tu boleh rujuk lah. Buku nota belum sampai lagi Kalau dah sampai saya akan inform. Okay, we look at calorimetry and then we look at definition. Anda boleh tengok juga definition. Okay, so heat capacity. First we look at heat capacity. Definition of heat capacity. Heat capacity, the symbol is capital C. Capital C. Of a substance is the amount of heat required to raise the temperature of a given quantity of a substance by 1 degree Celsius. Okay, so normally the unit is joule per Celsius. Okay, joule per Celsius. The second definition that you need to know is specific heat capacity, which is a small c. Okay, small c. Specific heat capacity of a substance is the amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. So here we mention about joule per gram, ada mass and per Celsius. Okay, this is the two important definition that you need to know for the first part of calorimetry. Okay, next is all calculation. So we will have two types of calorimeter. Kita ada dua jenis calorimeter. Number one is known as Bohm calorimeter. Number two is known as Bohm calorimeter. Another one what? Cup calorimeter. Cup calorimeter. Ada nama spesifik tak? Cup lah. Cup calorimeter. Ada orang panggil Koff calorimeter, cup calorimeter lah. So Bohm calorimeter and cup calorimeter lah. Okay. Just a moment Simple calorimeter pun ada lah. Cup calorimeter dia ada banyak nama Simple calorimeter, cup calorimeter and so on lah. Coffee cup calorimeter semua tu ada lah. Dia belum keluar lagi sebab saya rasa internet slow lah. Alright, so we go to the calculation part. Kita pergi ke calculation part You boleh tengok slide number 2. Calculation part We start with number 1, Bohm calorimeter. Okay, number 1 is Bohm calorimeter. We straight away go to the formula. Okay. Normally, this Bohm calorimeter used to calculate enthalpy of combustion. Okay, enthalpy of combustion. Bohm calorimeter ni digunakan untuk kira enthalpy of combustion. So the formula Q system equals to Q reaction plus Q calorimeter. Q calorimeter plus Q water. Okay, so you can actually refer to Bohm calorimeter in your notes. Sebab dia berikan diagram yang lebih jelas lah. Okay, never mind. I try to show the diagram. Just a moment. Saya cuba tunjukkan diagram dia. Saya buka drive. Just a moment. Sorry. Sekejap Sila tengok notes. Just a moment. I'm trying to open the diagram for Bohm calorimeter. Simple. Okay. So this one. Alamak. Just a moment saya tengah buka dia punya ini apa? Slide dia tunjukkan Bohm calorimeter. The internet dah quite slow. Baru tu nak buka dia pun lambat Okay, dah jumpa. Can you see the diagram for Bohm calorimeter?
Yes, sir.
I make it bigger, so that you can see. This is Bohm calorimeter. Okay, you can see the Bohm calorimeter. Okay, so you look at the formula in the Jamboard. Saya dah tulis Q system sama dengan Q reaction tambah Q calorimeter tambah Q water. Okay, so I just explain here. What happened is you put the compound inside this steel Bohm. You can see this is called steel Bohm. So you put whatever compound you want to find the enthalpy of reaction, the enthalpy of combustion of that compound. You place the compound in the steel Bohm, and then you turn on the electrical connection to the ignition wire. So it's like toaster. Tahu toaster? You toast the bread, right? Or your microwave, a similar concept. So you on the electrical connection to the ignition wire, and the ignition wire will become heated wire, and it burns the reactant inside the steel Bohm. It combusted the reactants inside the steel Bohm. So once the steel Bohm burn inside the steel Bohm, once the reactant burn inside the steel Bohm, it will release heat to surroundings. Now, surroundings inside the insulated container is water. You can see So steel Bohm ini dikelilingi dengan air. So bila reaktan dalam steel Bohm ini terbakar, dia akan bebaskan haba. Haba tu akan masuk just a moment Okay, sorry about that. So bila reaktan dalam steel Bohm ini dia terbakar, dia akan bebaskan haba ke air. Haba akan dibebaskan oleh reaktan yang terbakar ini, dan air yang mengelilingi steel bomb ini akan menyerap haba itu. Once the water absorb the heat, thermometer di sini akan menunjukkan peningkatan suhu. So temperature raise can be read here from the thermometer reading, because when water absorbs the heat, obviously the temperature reading will increase. Okay, so you can see the thermometer reading rises lah. Okay, the purpose of stirrer di sini adalah untuk menyeragamkan haba, to make the heat distributed uniformly. Okay, the heat will be distributed uniformly throughout the entire insulated container. Tu kita gunakan stirrer lah. And then perhatikan, ini adalah insulated container penebat. Kalau dalam BM tu tebat lah, penebat lah. So that means kita anggap kita punya heat not lost to surroundings. Haba tidak keluar daripada sistem ke persekitaran sebab kita gunakan insulated container. Okay tak guys? Boleh ke bomb calorimeter ni? A simple device. Kan boleh dengar ke?
Boleh, sir.
Boleh Okay. So now kita pergi ke Jamboard. Jamboard tu anda boleh tengok lah. So Q system sama dengan Q reaction tambah Q calorimeter tambah Q water sama dengan kosong. Because kita gunakan insulated container, kita assume no heat loss to surroundings. Okay. When no heat loss to surroundings, Q system sama dengan kosong, maka Q reaction, RXN is stand for reaction. Saya akan gunakan abbreviation lah. Q reaction equals to negative Q calorimeter plus Q water. Okay, so ini adalah formula untuk bomb calorimeter. That is the formula for bomb calorimeter. So this one I stop sharing. Mungkin ada yang tak nampak. Saya akan share Jamboard lah. Boleh tak anda view dekat Jamboard anda? Sebab sini Jamboard sangat slow lah. Can you all view at your Jamboard? Because my Jamboard the tak appear lah. You punya keluar tak? Okay. So you all sorry lah sebab internet lagging kot. Tak keluar dekat saya punya Jamboard dekat laptop. Tapi iPad saya memang saya tulis lah. So saya harap you boleh view lah. So itu adalah bomb calorimeter punya formula, anda kena tahu. Okay. Now kita pergi ke simple calorimeter. Okay, saya ambil slide number 4. Saya dah pergi slide number 4. Slide number 4. Slide number 4. Okay, slide number 4, we will look at simple ataupun cup calorimeter. Cup calorimeter, simple calorimeter, satu lagi coffee cup calorimeter, semua boleh. Ini biasanya enthalpy of neutralization. Okay, biasanya lah. Kita eksperimen pun kita kira enthalpy of neutralization lah. Alright. So this one is simple one lah. Kalau saya nak tunjuk gambar aja dia, kita tengok slide nota juga. Nothing actually. Control F5. Okay, so I will share mana ni. Okay, tab. So nampak simple calorimeter, constant pressure calorimeter, dia banyak nama lah. Okay, kita tengok Okay, this is simple calorimeter. Oi. Kenapa tak keluar ni? Okay. Okay, this is simple calorimeter lah. Tak nampak, sorry Not very clear lah. But you can refer to your notes lah. So, we use a cup, styrofoam cup, and then we have a reaction mixture inside, and then thermometer and stirrer lah. Similar concept So thermometer to record the temperature difference, and then the cup will contain the reaction mixture. Because we are going to measure the enthalpy of neutralization, the reaction mixture refer to acid and base. And then kita ada stirrer. Stirrer ni macam tadi lah, to get the heat distributed uniformly, seragamkan lah. Apa tu? Haba tu disebarkan secara seragam dalam styrofoam cup tu lah. And the styrofoam cup is considered as the insulated container lah. Sorry, insulated container. Okay, kita akan tambah lagi kapas dalam apa tu, cup tu, supaya dia betul-betul insulate haba daripada hilang ke persekitaran. Okay, this is simple calorimeter, right? So you can refer to your apa ni nota pun lah, boleh tengok nota. Dalam nota pun ada apa tu, gambar aja simple calorimeter lah, ataupun you Google also, anda Google pun anda boleh nampak simple calorimeter macam mana diagram dia. Okay, also similar concept, Q system equals to Q reaction plus Q calorimeter plus Q solution. This one a bit different. No water, Q solution equals to 0 because we assume no heat loss to surroundings. Okay, no heat loss to surroundings. So that means our Q reaction sama dengan negatif Q calorimeter tambah Q solution. Okay, ini adalah untuk formula untuk simple calorimeter. Okay, tadi bohm calorimeter, ini simple calorimeter. Q, we have two different formula to calculate. If we use heat capacity, C besar delta T. If we use small c, specific heat capacity, then MC delta T. So this is the two formula we use to calculate the Q. Okay, sama ada dia melibatkan heat capacity ataupun specific heat capacity. Okay, that's all teori dia. Teori dia simple habis. Sekarang kita buat latihan, buat soalan. Setakat ni okey ke? Boleh saya proceed ke atau ada soalan nak tanya?
I'll proceed, sir.
Can I proceed? So to proceed, since everyone is here, start dengan question 5. So proceed with question 5, tutor 9.1, 9.2. Okay. So read the question first. I give 1 minute. Baca dulu soalan. Okay, so mungkin dah baca soalan tak apa, ini first contoh saya akan tunjukkan lah. Contoh satu saya akan tunjukkan macam mana dia punya calculation. Okay, when 2.05 gram of naphthalene C10H8 is burned in a bohm calorimeter. So they already mentioned we are using bohm calorimeter. Okay, info sudah diberikan. Dia melibatkan bohm calorimeter. And the temperature rises by 7.2 degrees Celsius if the heat capacity is 5.11 kilojoule per Celsius. Question A, they want us to define standard enthalpy of combustion of naphthalene. Okay, so I don't want to write here. I just read it out. See whether you can get the same definition later. Okay, standard enthalpy of combustion of naphthalene is defined as heat release when 1 mole of naphthalene completely combusted in excess oxygen at standard condition, temperature 298 Kelvin and pressure 1 atm. Dapat ke? Dengar ke?
Ya, dengar sir.
Okay, I will repeat one more time. Mungkin ada yang tak dengar. I repeat one more time. Standard enthalpy of combustion of naphthalene is defined as heat release when 1 mole of naphthalene completely burn in excess oxygen at standard condition, bracket, temperature 298 Kelvin and pressure 1 atm, close bracket. Okay, itu definition dia. Right. Then B. Okay, calculate enthalpy of combustion for naphthalene. So this is where we are going to use our concept Bohm calorimeter. So we check what are the other info given. One, we know it's a Bohm calorimeter. Second one, they give you the mass of naphthalene. Dia bagi 2.05 gram. Then what else they give? They give the temperature rises by 7.2 degrees Celsius. So it's delta T equals to 7.2 degrees Celsius. The heat capacity, capital C, is 5.11 kilojoule per Celsius. Okay, these are the info given. And we need to find, the question wants us to find the enthalpy of, standard enthalpy. Oh, sorry, enthalpy of combustion, not standard. They want us to find the enthalpy of combustion. So, since kita gunakan Bohm calorimeter, so kita punya formula mula dengan Q system equals to Q reaction plus Q calorimeter plus Q water. Okay, water ataupun H2O boleh lah. Simple kita letak simple. Q H2O equals to 0. No heat loss to surroundings. Okay. Therefore, Q reaction equals to negative Q calorimeter plus Q water. So this is our formula to calculate the Q reaction. Now, saya nak ingatkan di sini, reaction ini dalam kes ini merujuk kepada combustion of C10H8, that is naphthalene. So reaction itu merujuk kepada combustion of C8H10 iaitu naphthalene. Maksudnya di sini Q reaction adalah kita kira enthalpy of combustion berapa. Okay, itu maksud dia lah. So we have to check information yang ada kat kita. Okay. Is there any information about what do you say? Calorimeter? Ada tak apa-apa maklumat tentang calorimeter? Kita tengok dekat info. Yes, ada kat sini dia bagi heat capacity untuk calorimeter. So ada info. Maksudnya Q calorimeter kita boleh kira lah sebab ada info heat capacity of calorimeter. Okay, next, ada tak apa-apa info tentang water? Kita check. Tentang water tak ada. I read the entire question, I look at the info. There's no information about water, maka ini akan jadi kosong. Sebab memang tak boleh kira lah, tak ada apa-apa maklumat. There is no information in the question to or regarding about water. There is no information about water in the question. Therefore, our Q water become 0. Boleh ikut setakat ini tak? Ada soalan nak tanya?
Boleh,
Okay,
sir.
so far? Okay, so kita sambung. Saya pergi slide seterusnya. Ya, anda boleh gerak ke slide 6. Okay, so saya tulis formula dulu. Q reaction sama dengan negatif Q calorimeter. Sebab Q water kita kosong lah. So, negatif diberikan heat capacity C besar delta T. Okay. C besar kita adalah 5.11 kilojoule per Celsius darab dengan kita punya delta T 7.2 Celsius. Okay. 7.2 Celsius. Jadi kita boleh cancel. Celsius boleh cancel. Maka kita akan dapat dalam kilojoule, kita kira 5.11 times 7.2. So I get negative 36.79 kilojoule. Okay. Kilojoule Dapat ke? Negative 36.79 kilojoule?
Dapat, sir.
Dapat Okay, kita ke slide number 5. We go to slide number 5. Okay, remember, saya lupa nak highlight di sini. Your enthalpy of combustion, sini atas ni, enthalpy of combustion, sebab kita define tadi untuk 1 mol, so unit dia mesti kilojoule per mol. Remember, the unit of enthalpy of combustion must be kilojoule per mol. Kilojoule per mol. Okay, so that means kita ke slide number 6, kita baru jumpa jawapan kilojoule. Belum lagi per mol. Kita baru jumpa kilojoule. We just found the kilojoule, not yet per mol. So what we need to do, they give us mass. So they give the mass of naphthalene. Mass of naphthalene 2.05 gram. So mole will be mass divided by molar mass. So 2.05 gram. Kita kira molar mass dia 128 128 gram per mole. So cancel the gram, we will get in mole. 2.05 divided by 128. I get 0.016 mole. Okay, 161 pun boleh lah, 16 lah. 0.016 ataupun kita ambil sekejap sebab dia ada 3 angka berarti, so saya ambil extra lah, 0, 2. Okay, 0.01602 mole. Mole naphthalene C5 C5 pula. C10 H8. Okay, that is the one. So our understanding here, you have to listen carefully. Dengar betul-betul. Understanding kita adalah, kita punya understanding 0.01602 mole of naphthalene release 36.79 kilojoule. Okay, so if I go to next slide, slide number 7, saya akan tulis statement dia macam ini 0.01602 mole C10H8 release negative 36.79 kilojoule. Okay, ini statement kita dapat daripada slide sebelum ini. Okay, slide sebelum ini Q reaction kita iaitu heat of combustion kita. Reaction kita merujuk kepada combustion. Okay, combustion kita bebaskan 36.79 kilojoule. Kemudian kita kira mol yang terlibat dalam eksperimen ni 0.01602 mol. So statement kita pada slide seterusnya adalah 0.01602 mol naphthalene releases 36.79 kilojoule. Therefore 1 mole. Okay, kenapa 1 mole? The question is why I am talking about the 1 mole. Okay, reason very simple, because we are going to calculate the enthalpy of combustion. And we already learned enthalpy of combustion should be referred to 1 mole. So berapa dapat di sini? Kita boleh kira lah. So minus 36.79 kilojoule divided by 0.01602. Okay, kita kira Saya dapat negatif 2297.1 kilojoule per mol. Okay. So kita buat kesimpulan. Enthalpy of combustion of naphthalene C5 juga C10H8 naphthalene equals to minus 2297.1 kilojoule. Okay tak guys? Faham ke nak tanya soalan? Boleh tanya, silakan. Okey ke?
Yeah, okay, sir.
Okey. Isiang okey. Yang lain macam mana Dapat kira ke? And this is what called the first important part of chapter 9 that will be asked in your PSPM. Memang popular dalam PSPM lah, calorimeter ni. Anda boleh tengok pasti memang ada calorimeter punya soalan. Setiap tahun cuma tak tahu dia nak tanya simple calorimeter ke boom calorimeter. Itu je beza lah. So this is boom calorimeter. So after this you need to practice thermochemistry is like mathematics. Similar to your chemical equilibrium kan. Dia kena practice banyak baru boleh ni lah. Sebab dia I think about 90%, more than 90% is about calculation. So you have to do a lot of practice lah. Okay. Alright. So if boom calorimeter settle, kita akan buat satu soalan simple calorimeter. Okay. Move to slide number 8. And we are going to look at question number 4. Question for tutor 9.1, 9.2. Okay. So sama-sama kita baca soalan dia. When 200 ml of 1 molar sodium hydroxide, so I have a beaker. Okay, beaker ini ada 1.00 molar NaOH with 200 ml. Okay, 200 ml. And then mix with another beaker. Which contains same molarity, 1.00 molar, but ACl, acid, with 150 ml, the volume. So you are going to mix both into a styrofoam cup. Okay, we are going to add both into a, of course with the insulator lah. Okay, sini kita ada insulator. Insulated styrofoam cup lah. Okay, insulated styrofoam cup. So we are going to add both into a styrofoam coffee cup calorimeter. Okay, so the moment you see the word styrofoam coffee cup calorimeter, that means dia merujuk kepada simple calorimeter. Okay, simple calorimeter. And then they kata temperature rose from, so you add here, you have thermometer, thermometer. So T initial is 25.00 degrees Celsius and T final is 30.00 degrees Celsius. So after you mix, you put a stirrer there. Okay, you stir and then you record before and after. Before mixing is 25 degrees Celsius. That means ini pun 25, yang ini pun 25. Okay, degree Celsius lah. And empty calorimeter pun tanpa air, temperature dia 25 degrees Celsius. After you mix both, you stir them and then you place a thermometer and record the temperature. The final reading show is 30 degrees Celsius. Okay, peningkatan suhu yang ditunjukkan adalah 30 darjah Celsius selepas dicampurkan dan dikacau lah. Okay. So the question wants us now to find the enthalpy neutralization, and they said the specific heat capacity of the solution is assumed to be, so saya letak sini C solution. C solution maksudnya specific heat capacity of the solution 4.18 joule per gram per Celsius, and then they give you the density of the solution is 1 gram per milliliter. 1 gram per milliliter. And kalau kita perhatikan kedua-dua info ini untuk solution ni adalah sama dengan water, because water's density is 1 gram per milliliter. So now we are going to calculate the enthalpy of neutralization. So we will have formula here. First, before that, we have to calculate the step. The calculation step begins with calculating number of moles. Okay, kita mula-mula kira number of moles. So we calculate number of moles of NaOH, MV over 1000. This is the first step. Okay. M is 1.00. Kita dah tengok tadi. V is 200 divided by 1000. So this is 0.2 mole. Okay. Then the second one. Next, we have to calculate the mole of ACl. The molarity is 1.00, same. Volume is 150 divided by 1000. So this is 15. I get 0.15. 0.15 mole. Okay. We get 2 moles here. Second thing, kita perlukan equation. Acid base, definitely we need equation. Remember, definitely we need equation. So the equation is NaOH equals plus ACl equals produces NaCl equals plus H2O liquid. Okay. So just to refresh what we have learned previously, when we are talking about enthalpy of neutralization, the focus is in 1 mole of water, because the definition, kalau dari segi definition, enthalpy of neutralization is defined as heat release when 1 mole of water form from neutralization between acid and base at stated condition. Okay, so our water has to be in 1 mole lah, itu compulsory. Okay, so now we look at this equation. Kita tengok equation, saya padam ni I erase this one because I already explained. If I look at the equation, the mole of water, NaOH is 0.2 mole, ACl is 0.15 mole. Okay. So these are the information so far we got it. Next is the third step. The third step is we calculate the enthalpy. Okay, so Q system means your Q reaction equals to negative Q calorimeter plus Q solution. Okay. Now kita pergi ke info, macam tadi juga, macam bom calorimeter, kita pergi ke info. We go to info. Info yang kita tengok tadi. Okay, let's look at the info. What are the info given? Do we have any information about calorimeter? Can someone tell me? Ada tak apa-apa information tentang calorimeter di sini? Untuk mass calorimeter ke, heat capacity calorimeter ke, ada tak?
No, sir.
No. So apa kita boleh buat? Kita pergi ke formula ni, we make it our Q calorimeter become 0. Jadikan kosong. Reason very simple, because there's no information about calorimeter. Information here meaning neither they give the mass nor the heat capacity or specific heat capacity. Both information are not available. So kita jadikan itu kosong. That means our conclusion here, Q reaction equals to negative Q solution. Is there any information about solution? Cuba tengok ada tak?
Yes.
Do they give any information about solution? Ada ke?
Yes, sir. Ada.
Nampak sini? Ada. So dia bagi specific heat capacity of solution, dia bagi density of solution. So dia bagi dua-dua. Okay? Alright. So kita patah balik ke slide number 9. So kita kata sini kita boleh kira Q reaction equals to negative M solution C solution delta T. Okay. So we go and find one by one. Kita cari ini one by one. Okay, slide seterusnya nombor 10. We try to find the M solution first. Okay. Perhatikan density of solution is given 1 gram per milliliter. And we know the formula density equals to mass of solution divided by volume of solution. Okay, so density is given 1 gram per milliliter. Mass of solution kita nak cari, kita tahu Volume of solution, yes. Kita pergi ke slide number berapa tadi? Number 8. Go to slide number 8. Okay, kita ambil 200 ml. Masukkan ke sini, kita ambil 100 ml, 150 ml, sampul ke sini. That means dia punya V solution sekarang akan jadi 350 ml. Okay, setuju? Do you agree with me? It become 350 ml.
Setuju.
Setuju.
Kan? Yes. So kita pergi ke slide number 10. Okay. Is 350 ml. Maka mass of solution sama dengan 1 gram per milliliter darab 350 milliliter. Milliliter cancel 350 gram. Okay. But mass of solution 350 gram. So, patah balik. Sini formula ini mass of solution sudah jumpa. Okay. Sudah jumpa Nak ganti terus pun boleh lah. Kita ganti terus T initial. T final is 30. T initial 25.00. That means this is 5.00 Celsius. Delta T lah. Okay, dapatlah 5.00. So, pergi ke formula ni 5.00 Celsius. Tutup bracket. Ni bracket jadi besar sikit kecil sangat. Make it bigger one. Kita letak warna lain. Okay, this is the bracket. So apa yang kita boleh cancel di sini? You can check. Gram boleh cancel. Celsius boleh cancel. Okay. So what is the value of therefore? Therefore, Q reaction sama dengan negatif 350 times 4.18 times 5. 7315 kilojoule. Dapat ke? Cuba tengok. Can get? Ke dapat nilai lain? Cuba bagi tahu saya kalau dapat nilai lain.
Dapat, sir.
Okay, not guys, dapat tak?
Dapat, sir.
Oh, dia tak ni Dapat alamak, kenapa dia sharing dah tutup Sekejap, saya tertekan. Tak apalah, dia slow kan. Saya pun tak slow sangat ni. Tak apa, that's okay. You boleh dapat Jamboard kan? Okay, 7315. Okay, kena ingat sila pergi ke slide number 10. Okay, the Q reaction, the neutralization reaction, baru dalam unit kilojoule kita kena ingat kita punya neutralization unit dia mesti kita pergi ke equation yang kita buat tadi pada step number 2 tadi, step number 2 equation ni anda boleh perhatikan. So di sini kita punya NaOH 0.2, kita punya HCl 0.15. So kita kena pilih limiting reactant. Siapa punya mol lebih kecil? NaOH ke HCl? Which one is smaller?
HCl.
Which one is smaller? Oh, this one is having problem.
HCl, sir.
HCl is smaller. Very good. So you can look at the Jamboard. I think sharing here got problem. Okay. So 0.15. HCl is the limiting, right? Limiting reactant 0.15. So kita akan gunakan water kita pun 0.15 berdasarkan limiting reactant. Now kenapa dia pun 0.15? Perhatikan HCl pun 1 mol stoichiometry dia, water pun 1 mol stoichiometry dia. Ratio dia 1:1. So kalau HCl 0.15, H2O pun 0.15. Dan again, kenapa kita gunakan HCl? Sebab dia limiting. Dia lebih kecil daripada NaOH. So, ke slide number 10. Go to slide number 10. Sorry, just now lost connection. Okay. Go to slide number 10. Okay, kita akan sebut 0.15 mole water releases 7315 kilojoule. Therefore, 1 mole water. Okay, remember, I want to repeat here why we say 1 mole. Okay, kenapa kita sebut 1 mole? We say 1 mole because our enthalpy of neutralization has to be in the unit kilojoule per mole. Remember that, enthalpy of neutralization, unit akhirnya mesti kilojoule per mole. So, minus 7315 kilojoule divided by 0.15 mole, and we will get this one, kilojoule ke joule tadi sorry. Just a moment I just want to recheck. Joule, not kilojoule. Sorry guys. Sorry No wonder it's joule Sila ke slide 9. Sorry about that It's joule, not kilojoule. Sebab tu nilai dia pelik. Dia joule Ni joule. So ini bukan kilojoule, ini adalah joule. Okay. Dan sini slide number 10. Dia pun joule bukan kilojoule. So sini pun joule. Right. So ini joule. Alright. So I get minus 487 66.7 joule per mole. Okay. So kita tukarkan kepada kilojoule. minus 48.77 kilojoule per mole. Okay, so heat of neutralization negative 4877 kilojoule per mole. Okay, cuba tengok dapat tak nilai ni. Sorry tadi saya tersilap unit. Dia joule bukan kilojoule. Slide number 9 tadi. Okay, sini Sini sepatutnya dia joule lah. Okay tak so far?
Okay, sir.
Sorry saya tak dapat nak sharing. Saya pun tak tahu kenapa tak dapat. You cannot see, right? Can you see any sharing?
No, sir.
Baru keluar. Because the internet is not good lah. Okay, this one I say just now. Sorry about that. Saya terlepas pandang ni. Ini joule bukan kilojoule. So sini joule, maksudnya sini joule lah, bukan kilojoule joule. And then if you see here, I already cancel dia bukan kilojoule, joule. Sini pun joule, sini pun joule. So we get 48,766.7 joule per mole. And then it has to be in kilojoule. So I divide by 1000. I convert into kilojoule per mole. Okay, and then finally I make the conclusion. The enthalpy of neutralization is minus 48.77 kilojoule per mole. Okay, not?
Okay, sir.
Okay, so I think that's all for today's lesson because it's already going to be 9 o'clock. You have next lesson. K1 P2 saya akan jumpa dalam pukul 11 nanti untuk lab lah. So I hope next week we can have physical class. I really hope. I really do. If any one of you are still having the MUED exam next week, everyone finished already, right?
So mine is on 26 next Thursday. Okay, next Wednesday.
Oh. Next Thursday.
Wednesday.
24, 25, next Wednesday lah.
Yeah.
Okay, never mind. Wednesday, yeah. Never mind. What I hope is next week. I really hope we can come physical class lah. I really hope because this is very difficult. This is very difficult for me to teach online because connection always lost and then lagging of internet. You can't hear me. I can't hear you. So I hope really we can do physical lesson next week lah. Okay.
Yes, sir.
Okay, so meanwhile, I already teach you 9.1. Now, today we have completed 9.2. So, those who have learned 9.1, 9.2, I mean the whole class, all 3 classes, you can start to do the Tuto Meka Kumbha chapter 9. Okay. In our next tutorial class, we will discuss the solution. Boleh?
Boleh, sir.
Okay, lesson 9.1 saya rasa dah upload Saya dah upload. Anda boleh check di YouTube memang dah ada. 9.2 ni yang kita buat ni, dia kalau Google Meet ni dia memang ambil recording dia lama sikit nak dia datang ke drive saya. Tapi once it comes to my drive, I will immediately upload to you lah in the YouTube. So stay alert lah. Nanti saya akan update dekat Telegram. Okay, that's all for today. See you. Do not forget to key in the consultation. Saya perlukan 3 people, any of you, any 3. Any one of you, 3 of you help me to key in the consultation. 3 of you, Thank you very much. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir.
Thank you, sir.
Sir. Thank you, sir.
Yeah, welcome.
Thank you, sir.
Welcome. Bye-bye. Yeah, sure. Bye-bye. Welcome. Bye. Yeah, welcome. Bye. Bye-bye. Terus. You sangat true, murni. You tahu, dia kita kan sharing kan, present sharing kan. Saya sudah sharing, tapi sharing tak keluar. Loading pun tak ada, apa pun tak ada. Tiba-tiba button tu jadi gelap, you tak boleh tekan balik.